I'm started now. Cool. This is your slide, right?
Hello all, this is Shreyansh. I am working as a full stack developer in a company called Xebia. But my topic is here AI in JavaScript with the help of React.js. So you may think that as a full stack developer, how I know AI. So I got one chance when I want to finish my BTech on Premier Institute. I was associated, and there I was I worked on AI, little about machine learning and deep learning kind of stuff in one DRDO research funded project. And because of the COVID and all, it didn't went well. The funding got over and all. So the thing is that from then I started my career in web development, as I am interested in web also. So from then I'm working as a full stack web developer. But still, as I learned web like AI ML, so in my one of my company which is providing software solution to the police, and they are using face recognition on the web. So I have worked on that face recognition, as they know that I'm interested in AI ML also up to certain extent. So they have given me the work, and I have worked there as a in a face recognition server, and we have successfully executed it, our work and things like that. So I have not got chance again to work on AI ML, but my topic is here that how we are going to perform AI ML with the help of JavaScript. And usually Python is most popular to do AI ML related work because of their diverse library, because of their diverse way of handling the data and things like that. But some use cases is there where you will not able to perform AI ML in Python, because once the real-time processing is needed in AML work, like Google Meet is there, where you can see that your background blur is happening, real-time object segmentation is happening, and things like that is happening. In case of Adobe also, they have one Photoshop server. Like in case of Google Meet also, when you are typing something wrong, then instantly the like using generative AI, it will came into the picture that this is wrong and things like that. So all is happening in WebML and WebDL only. And like many big company came with multiple evolve library, and the counterpart of a JavaScript library to implement WebML. So that is the context of this talk, to like how we will able to do it in JavaScript with the help of React.js. And if we will do it as you know React, if anyone know React, you know that Node package manager is there and PM is there to deal with the React. So if we will install something with the help of npm, we will do same thing with the help of Node also. We will able to generalize it with Node also. But here my context is with the help of React.js real-time operation, like we are that is happening in case of Google Meet and other things. And that is popularly called today WebML and WebDL. So few are the libraries like TensorFlow.js, Brain.js, OpenCV.js, which is the counterpart of OpenCV. Those who know little machine learning and deep learning, they know that OpenCV is most popular for doing video recognition, real-time audio monitoring, face recognition, and things like that. They are using hard cascade. They are using other kind of algorithm to perform the operation and things like that. So the thing is that let's get started with AI. So let's get started with machine learning first, which is the most used cases. So I have prepared some slide which will going to give you the like some kind of main machine learning algorithm how we will going to perform. And I have taken multiple coding example also, so that you will not be fearful how we will able to do it with the help of JavaScript. It is simple only that we are using to perform it in Python. Same way we will going to use it in JavaScript also, and it will going to happen in real time, because we are not hitting any backend server like a Python backend or even Node backend and things like that. It will going to happen on the browser. So that is the thing. So let's get started with the linear regression, which is one. Like here you can see the two data is there, which is the two class classification problem. Like two kind of data is there. So using this, as it is separable by linear line, using y is equal to mx plus c, and finally we are going to separate it with the help of linear line. So this is a linear regression for separating from classification of two class classification problem. And now get started with the code of the JavaScript code of the linear regression. This is the code. You have to implement npm install ml.js, and from that ml.js directly you will going to train your data, and finally you will going to match the data. One parameter is here size, one parameter is here price, and finally we will able to approach simple linear regression, which is one free API providing simple linear regression model. So here the abstraction is must there. There are multiple ways to operate some same kind of thing. Like here abstraction is there, it is getting optimized. Like sort function is there already. Someone written sort using bubble sort to give a log and base 2 complexity or things like that. So directly we can also use, if you don't know that much, you can use, and we can perform our work, and finally we will going to predict our model with the like predict 820, like 820 will give how much value, and depending on the model training, it will going to fit one straight line, and finally it will going to predict the value depending on what the model we have trained, and using this simple regression, linear regression API. And that is using, and one more thing is using TensorFlow.js. Like TensorFlow is maintained by Google, and they have created the counterpart TensorFlow.js for doing WebML, WebDL thing. So using TensorFlow.js also we will going to operate same thing. Here we do have some more accessibility. We can able to put which kind of loss we will going to operate, which kind of optimizer we will going to tune. Like say this is SGD, so statistical gradient descent. Those who know, it is a Bayesian curve shape thing, and using convergence algorithm it will going to minimize the error and all. So as it is a linear regression, it is simple. Finally we are using with the help of tensor, which will going to give more access to the multi-dimensional matrix calculation and things like that. Finally we will going to predict the value, and this is the simple code to implement linear regression with help of TensorFlow. And same way, this is the neural network.js. I'm giving more and more library to give you insight at how much flexibility we do have and how much more we can do with the help of JavaScript. And day by day, the community is getting rich, because when you have app, you have web, and you want to perform real-time machine learning and deep learning stuff. So you do have multiple options to do and opt in your app also. Like especially with React, we will generalize it with React Native to do in mobile application development and things like that. So day by day, it is getting popular, and day by day, this library is also getting enriched. So here again, the input is there, output is there in terms of, and finally we are tuning it with the neural network. I will going to talk about neural network little later. So finally we are going to talk train with neural network, and finally this is the iteration, like how many times iteration we going to do the batch processing. Like training data will go into the neural network, and finally we are predicting the value, like predict 5, and it will going to give the output. And this is like new NN is also one kind of API that provided by neural network.js to do our work. So now linear regression, almost I saw three examples. So now let's come back to the logistic regression, which is also like two-class classification problem. Like we are doing binary class classification depending on 0 and 1. We are doing depending on the threshold value what we have set, and we are going to do the logistic regression. As it is a regression, so we will going to predict any value depending on the whatever the curve fitting is done by machine learning and deep learning. So finally, depending on the threshold here, it will going to give two-class classification, whether cat is there or dog is there, and things like that. Now you will also think that why I'm telling about only two-class classification, what about multi-class classification, because real life example will be different and complex. So I will talk about that also little later. So these are the like logistic regression. This is the sigmoidal curve, and this is the activation function, which will going to give our data in between 0 and 1 only. When you going to multiply anything with this data, it will going to give 0 and 1. And like that only, many activation function is there to tune our model up to the output whatever we want and things like that. So these are the again Avel.js is there to perform the logistic regression. Again, you have some data like space, like this is space. Okay, so like we do have some data, like it is coming under this. So these all are the data, like 0 will give this is x variable, this is y variable, one is dependent, one is independent variable, and things like that. And finally we are doing the leveling of data. This will give 0, this will give 1, this will give. Finally we are going to train. Those who know little machine learning, first we should have to train with multiple data, and finally with that data the prediction will going to happen on a known kind of data. So here also we have one API called logistic regression API, and finally we will going to train it with that API, and finally we will going to predict the value depending on in which class it will going to belong, and either it will give 0 or 1, as it is a binary class classification problem of logistic regression. And here using TensorFlow.js, we can also approach same thing with the help of tensor. These are the data like train X, train Y, and finally we are treating the model, sequential model we are defining, which is the simple model to predict, and finally we are adding one dense layer, which is like in neural network you will going to see that. And here it is giving much more flexibility also. Sometimes like some optimized API we are calling, and finally we are getting some outputs. Maybe we don't like that kind of thing. We want to train our model with different kind of values. So here we will be able to change it. Like here we are using sigmoid function that you saw. It is a sigmoid kind of function. And like binary cross entropy loss is there, statistical gradient descent optimizer is there, that you can also change and you can tweak it to perform for your data. So it is giving the option And finally pose is there, like how many times that training will going to happen, and more approach will be there, more and more accuracy will be there. Those who know basic of machine learning, they will catch my term and all. So and finally we are predicting with the help of TensorFlow JS also logistic regression. And using brain.js also, we will be able to perform same using neural network API. And this is the activation. Again, here they are giving facility to choose the activation. As we know, it is a binary classification, so we have given sigmoidal, and it will going to give more accuracy. And finally, we are again after here iteration, we can define log period, we can define, and finally we will able to predict that value. Now coming to one of the most used cases of the supervised learning. I started with supervised learning like linear logistic, and this is supervised learning SVM cases. So SVM is support vector machine. Here for the simplicity, I again took the two class classification problem, and like here you can see that two class classification, so they are separating it with one line. And that is called, and if it is in the 2D, then we can separate it with the line. If it is in 3D, then we can separate it with the hyperplane. It will go plane, like line to plane to hyperplane. It is a like somewhat mathematical term that maybe you aware or don't aware, I don't know. But the thing is that here finally that is a vector. This left and right margin is there. Finally, that left margin is the which will going to touch the data is called support vector. This both left and right margin is there is the support vector, and finally we are maximizing our job is to maximize that plane length, plane width to and those like I have done some mathematics. I remember. So norm omega squared is the norm distance. Finally, that we have to minimize. Minimize to get more and more length. That I able to remember, but we don't go into that much deeper level. But finally, we are maximizing the thing, and we will able to perform two class classification and multi-class classification. Also, we will able to perform with the help of other thing like we will going to increase the dimension, we will going to increase tweak some value, we will going to change the activation function and things like that. So these are the SVM. Like see this, these are the simple examples. My context is to show you like that it is a simple thing. It is like Python. We are seeing some simple code is there like that. Also JavaScript we will going to perform ms.svm library. We will going to install, and finally we will going to train the data. And finally using this SVM is one API that they are providing. And finally this SVM, their kernel is there. We do have accessibility here to change the kernel and things like that, and cost function. And finally, we will be able to predict depending on whatever we have selected and things like that. And similar thing is happening with the help of TensorFlow JS. Also using Tensor, it is again we are predicting the data, and finally we are creating again one sequential model. And finally, with the help of dense neural network, we are getting the unit and which kind of activation we want: sigmoidal activation, ReLU activation, and many more activation is there depending on which kind of data set we do have. And depending on that, it will be going to give more and more accuracy with that data set. And finally, here also we can define optimizer SGD, statistical gradient descent, and loss in mean square error as it is happening in the plane line, as you saw, I think. So it is happening in the plane line. So if you will calculate the Euclidean distance, it will going to give more accuracy. That's why the mean square error is there. And finally, we can able to predict that what is the value of that for any unknown variable. What is which class it will belong to, whether X class or whether Y class, which class it will going to belong to. And TensorFlow already discussed. Now coming to the brain.js, again brain.js is there, which have again we should have to define similar way input, output, and using here also they are providing one API called neural network, and here they are giving option to change the activation function and hidden layer of the neural network. Those who know neural network, like there are multiple mode hidden layer which will going to do the back propagation algorithm and gradient distance and convergence algorithm to optimize further and further loss. And finally we are here we will going to give activation sigmoid and hidden layer. It depends on me that how much value we want. And finally we will able to predict the value data for any kind of a random predict the value for any kind of a random data, and it is a regression problem. So, this is also one kind of supervised learning use cases, neural network. So, neural network came from the human brain concept, like human brain have multiple neurons and all. So, it also came from the human brain concept to make human automated behavior. We will going to do multiple processing. So, we have, as you saw, there are multiple connected layers to like a human neuron and human brain. So, it is like one input layer is there, one output layer is there, and there is a dense neural network, multiple hidden layer is there depending on our output and all. And finally, we know at the time of training, we know that this input set have that output, and this input set have that output. And finally, in that while training, it will from output to input. It will going to back propagate, and finally, it will going to check the weight and bias. And finally, when we train with the multiple iteration and multiple approaches, then it will going to after training in a good amount, when we will going to give any random data, so if their weight and bias is fixed, like for this kind of thing, like let's take cat, dog, or 100 animal we have given, so have calculated all the weight and bias for all the thing, and finally we will going to give any random event that which class it is belong to. Then it will going to predict the value. Usually 90%, 85%, more than 90% is the accuracy. That's why this algorithm is giving. We also flexibility to change our activation function and like which kind of error we want, which kind of compilation we will going to use to get more and more accuracy. So these are the human brain concept like neural network, and that we already said like TensorFlow is using behind the scene and things like that. So these are the node brain. Node brain is library to design simple neural network. I have taken all kinds of examples, like if you are beginner and those who don't know that much, but still you have some work to do for machine learning and deep learning, then you can directly opt the machine learning model and things like that. This brain or neural network, we are creating net class, and finally using that class we are here iteration we will be able to perform. More and more iteration will be there, more and more accuracy will be there. After some extent it will be saturated depending on your data set and all, but finally we will be able to predict the value, and this is how the neural network is there. And here they have not given the option to change the hidden layer and all. So and later in this kind of using TensorFlow layers, we can also define the neural network. Here they are giving some more option, like unit is for what kind of input set, what kind of activation we do have. Like here you can see that is ReLU activation. Again, in one more dense layer have sigmoidal activation and things like that. And using Adam optimizer, which we're going to do gradient descent in a well manner. And using here also we do have access of giving loss function, what kind of accuracy we do want, and things like that. Finally, we will be able to change the epoch also that we saw last time. Also, they have given the iteration and epoch example. So the thing is that finally we will be able to predict. So multiple more libraries there, they are giving more and more flexibility for us to change whatever the thing we want to change to get more and more accuracy. So that is that we saw using TensorFlow.js. And finally, using brain.js also we can perform neural network. Here again we are taking one class .NET, and finally we are predicting the model and all. So now coming to the answer, that is the supervised learning class, like classification problem and things like that. And in case of multi-class classification problem, we will increase the dimension. We will going to change that, like it is a linear array separable, we will use linear line. Is it a hyperplane separable, we will going to use hyperplane by increasing one dimension. Like this kind of circular two data set is there, then in that case linear regression is not going to work. So in that two kind of data sets there in one circular format with different areas. So then in 2D we will not see that how we will going to separate these two circles. But if you increase with one more dimension, then it will be one like x, y, z plot you will do. Then it is again like same linear separable line. So we will going to increase the dimension to if we don't have any choice to do if our data set is that much complex and things like that. And we can change our like this loss function also. We can change our activation also depending on database, like sigmoidal activation, ReLU activation, like which is one kind of rectified linear unit, like negative value 0 and things like that. So you can explore more and more. If you want to perform some work, you can explore more and more about it. That is unsupervised learning cases. Now start with unsupervised learning when you don't have the level data. Right now we see whatever the example, we do have level data. Like we know that this input have that output, this input have that output, and finally whatever the model, it will going to predict some value depending on whatever the training example we have given and whatever the thing they have learned from there. But in case of unsupervised data, we don't know exactly we don't know data what kind of the class it belongs to. We don't somewhat mismatch is there and things like that. But here is only example. Unlabeled data is there, but we know like this data, this unlabeled data is belong to three categories, but we don't know exactly which one belong to which kind of category. So thereby like multiple algorithm is there for the clustering, like K means clustering is there. In that you can see that finally we will be able to perform like what kind of like finally K means clustering here, we are giving 3 centroid point, and finally it will going to check like distance from the centroid point, and finally it is always going to update the centroid, and it will going to calculate the mean, like two data statistics and x plus y by 2. That's why it means algorithm. K means algorithm, and finally like that only it will going to check that this class belongs to how much distance and all, and it will going to give as we have given 3 centroids, so it will going to plot three kind of data, and now it is getting level data, and finally we will able to perform the operation that we saw already with the level data. And because we will 2 minutes. So this is the unsupervised learning cases, and using this k-means algorithm, sk-means.js is there to perform the unsupervised learning, and using npm install sk-means is there to, as we know the number of cluster, and we will able to perform the like leveling of the data, and finally we will able to push in that again. We know level data, and we will able to perform any supervised learning use cases. And same thing is there using principal component analysis. It is there for feature extraction. Those who know machine learning, it is a very big term. So we know that we do have lots of data, is to physical data, multiple data, and things like that. When we know that this data is useful, but only few component of the data is useful. So we are here doing the dimensionality reduction to make the more insight of the data, rather than processing over all over the data. We are taking some more insightful data to do the principal component analysis. That's why we are calculating the principal data, and finally that like this is for low decreasing the dimensionality. That in that case we are increasing the dimensionality when our subset is very different and things like that. But usually we are doing dimensionality reduction for feature extraction technique. These are and this is the scikit-learn. Scikit-learn is a very big library for Python, and they have created counterpart scikit-learn.js and things like that. And using this basic new PCA, you will able to perform from higher dimension, like from 4D to 2D data and things like that. And we will able to predict that what kind of variance we do have, what kind of data, like what kind of reduced data dimension is there and all. So finally coming to the reinforcement learning, which is one more part of the machine learning. So using that, it is a bit complex because here we don't have any data and all. Here we are going to give reward penalty system to do the operation. Like the snake game we played in the childhood and all. So we are going in the snake game. So we know that our destination is that step, and we are going forward. And if it is after going one step forward, we are calculating the distance that we are reaching or not reaching. If it is going more, then we do have penalty. And if we are going towards that direction, we do have one kind of reward. So it is a kind of more evolved machine learning use cases when you don't know about any data and any use cases. So that is called a reward policy. And using Q learning is one of the algorithm to implement that. It will going to use one Q table, and every step we will going to perform. There is one reward, there is one penalty, and depending on that, wherever we have more reward, we will going to follow that path. And after that, our model will going to train with that also, even though we don't know the data and don't know the thing. This is one of the hot topic of reinforcement learning, and using Q learning and all, using Q table, that will going to give reward and penalty. We will able to train our model in reinforcement learning also. I have not added slide for the code. I have the code. Maybe I will show you after some time. But the thing is that code is a bit complex. It is not very complex, but 2-3 slide will going to have that, because iteratively we are going to call that function to give more reward or more penalty and things like that. But it is easier again to implement reinforcement learning also in with the help of JS. And now coming to the one more section of the AI, which is computer vision part. Like usually the computer vision, mostly we are using face recognition, face detection. I also worked on face recognition only with the help of JavaScript. So finally we are doing the image detection using OpenCV.js, face API there, JS is there, TensorFlow, multiple more libraries there. Object detection is also there. Sometimes you will able to define your own object detection. Sometimes you will able to use that pre-trained model that TensorFlow JS, Google is providing Coco SSD. Coco SSD already multiple object, like billions of objects is already trained, and from there we will going to show any object, and finally it will going to predict that this object belong to, like it is a mic, it is a mobile, or things like that. And finally we will able to perform face recognition also. After face detection, we will going to perform landmark detection, like landmark, like nose, ear, and things like that. It will going to give one kind of tensor matrices. And finally, if you have already data which is stored somewhere, it will going to correlate from that matrices that it is matching with any stored data, and depending on whatever the threshold, whatever the function you have given, if it is matching, then it will going to predict that this person belongs to that category, like Shah Rukh Khan or any kind of politician and things like that. So this is the image. Like finally, image detection will happen. It will going to give, like this is the hard wavelet using OpenCV.js. This is the eye hard wavelet you can able to use to detect eye also and things like that. And using this face API.js, using canvas is that rectangle and all in React. Finally, we will able to finally it will going to give the detected image, this detected image using this face API.js, which is trained for this purpose only. Using OpenCV.js also. OpenCV.js also we do have hard cascade XML, which will going to have the embedding of your face and all. It will going to detect the face using image detection will going to happen. And whatever I said you already, that we do have for image recognition kind of thing, it will again going to do the image landmark detection, and finally we do have some embedding stored. Finally, it will going to calculate the embedding to do the face recognition. And same way using WebRTC and all video processing like Google Meet kind of thing. So we will able to perform in the video, live video also all the processing. That's the thing. Like even though we know Python, then also we will not able to use Python for machine learning, deep learning work in some kind of use cases. Because especially when you are doing in web ML in case of the Google Meet and generative AI and all these things is happening like parallelly. Like it should be real time. So you don't have to hit any Python API and it will going to have further delay. That's why this WebGL and WebML concept is coming, and every company is coming with their counterpart JavaScript library to do much work. There's one more concept like NLP and all. I have not added because of the time constraint. But NLP also like chatbot preparation and all. Also you can explore with the help of JavaScript if it is real time, like generative AI, which is the NLP case. NLP.js is one library to explore more and more about that also. And that's about the talk to give you context about that how it can be implemented with the help of JavaScript. So you don't have to worry that we have only choice. But for data science concept, data science is always good to go with Python, because Python is very good to handling multiple data. And when we are predicting something, even one API call will happen, it will not going to harm us very much. But especially when something is happening on the web real time, so at that time you don't have to use Python, even though you are a Python developer for AI. You have to use at that time JavaScript to do real time processing and things like that. And one more thing, maybe you came into your mind, that how the GPU, especially this parallel processing and all, tensor and all, is heavily using GPU and CPU. So how browser have the GPU? So that's why this is a big thing. Like 10 year or 7 year back, that whole this Mozilla team and Google Chrome team came with one web GPU API. Finally, that API, when it is going behind in the browser, all the AI work is happening in the browser. It is using your system GPU and TPU if you have to do the AI related work on the real time. So that's the context of this talk, to go and explore. If you, as a JavaScript developer, it is more secure. You are not calling any server, backend server. So it is more secure. Your data breach will not going to happen. And some use cases that I said you multiple times. So you don't have even choice to do machine learning and deep learning in Python. You have to use JavaScript. So go and explore this library. That's why every example, 2-3 library I have taken: TensorFlow.js, Deep.js, OpenCV.js, Scikit-learn.js. All things you can implement, and you can generalize it with the Node application also, because same package manager is there in case of Node also. That's, thank you. Any questions?
Thank you so much, Shreyansh, for the talk. Any questions? Yeah.
Well, that was nice. I have a couple of questions though. Yeah, machine learning is and all good with Python, and we are trying to use JS. The question here is, how is it optimally using those functions that you showed just now, the library function? How are they optimally performing it? What's going in the background? I just wanted to know what's the latency of rendering it. If you're using a browser and you're building those models in the browser, and there's not any bare metal, right? Like in Python, you have your environment built in, all those stuff. So I just wanted to know what's the rendering time, or what's the delay in that. And also, if you're training a huge model and then you are using it, what is the kind of storage that you are going for? Like you need to store all the weights that you have calculated, and you need to store in a certain format. And sometimes it gets huge, and people store it into those zip files and all, or they use pickables, whatever is required. So I just wanted to know how is that better compared to Python when I'm using in browser. It has a lot of constraints, right? So can you address those things, please?
So first thing I said about the web GPU concept, that web GPU is there to do the work, inbuilt thing in browser. Python is the best choice when you know that after hitting one API call, finally we are getting result from Python also. So there is no choice to go with JavaScript. As I am a JavaScript developer. I am exploring deep learning and machine learning now also. So I will go, but as you know, but you don't have to go. But if it is like somehow like giving more delay and all, especially in case of but we saw already the use cases and all, especially for Google Meet, and usually many applications have AI/ML and all. So using that mobile application and all, then you don't have choice to go with Python, because it is happening in real time. Whatever the time it is taking, what you said is fine. Like as we are doing ML related work, deep learning related work, then it will take some time. But after that time, you are adding one more time if you are using with Python, one API hit, and API will going to give response. So that we are anyway minimizing in case of WebML and things like that. Apart from that you said that how we will going to perform it. So that's why this WebGL concept, WebGL is that API name that Mozilla, Chrome, and all are implementing, and they are heavily funding that also to operate more and more. It is internally behind the scene. It is using your computer hardware to do the perform the ML related work. And apart from that, you said about the storage and all. So storage and all, we will be able to perform anywhere. We will go to store. In case of Python, also you have to use some driver to store. Yeah, one in Python, especially that we can store more and more data. That I agree with. That's why I said that especially for data science kind of work, it is still good choice to go with Python, because we don't want that it should be in the real time only. But still in JavaScript also, Mongoose is there to store it in the MongoDB, or like the SQL, like using simplified library, we can download it, like store it in the PSQL and things like that. SQLite driver is there to store it in the SQL and all. Yeah, and we do have multiple more, like JavaScript is also very rich framework. If you will see their counterpart also, we will like store in JSON format also. We will going to have multiple library as a full stack developer. I know Excel.js is there to store in like Excel kind of format also, so that we can able to perform. Still Python is best set, but here we are not adding one API call. That's why it is the much more optimized compared to hitting that API when you have to do it real time. And storing wise, you can use any kind of driver and to do it. And regarding your main question that you there the Excel sheet and all creation is easy, and especially the like storage like in the JSON format and all is easy, and in Python I agree with. But still JavaScript also came with multiple more library you have to store the data either in the database or either in the Excel format or any kind of JSON format and things like that.
That's good. Any idea on the latency that you get after the?
Yeah, it depends. It depends on your hardware. It depends on your hardware. If you are using like a Google Colab and things like that, they are very much GPU, TPU processor is already there, so it will not going to give you latency. But if you will do in this laptop, it depends also on what kind of core you do have, what kind of GPU you do have, and things like that.
See, that's not my question. My question is, assume you have built your web UI and I'm using that, and I click to recognize an image, and you are doing that through React, right? So you would have stored a model which will be called and that will be rendered, and you are going to give the output then. I am asking, what is the latency for that? Is it, if that's greater than API, then there is no use of doing this. So if it is less than API, of course, then I agree with that. Is there any benchmark that you know? For example, like if you take some image, for example, like with some 10, 24 feet, something like that. What would be the latency for that? Why would I use that?
So first thing that I am doing it in the web. So whatever the you are telling rendering will go. Even though I am hitting the Python API, then also we have to render it in the JavaScript or React or Bengaluru, whatever the framework we do have using. So rendering is not one thing we have to do it. If it is happening on the web or mobile app, then we have to do the rendering activity after taking the data and all the things. So rendering is constant everywhere. Then one more thing is that API hit is there. API hit is unnecessarily happening in case of Python, because rendering, if you are
rendering, you are saying it will be the same time that you take to load a normal UI and this as well. I'm saying in this there might be more time taken to render, because you are invoking a model, right? Underneath it is invoking a model which will of course take more time than a normal rendering. What I'm asking is, what is the time taken normally benchmark to invoke that rendering? Is it greater than any API call?
Yeah, it depends. It depends. I will talk to you later also, but I have used in face recognition. It is not taking that much time. But if I will go with too much data set, it will take time. So there, in that case, we do have multiple React lazy loading and things like that. At that time, we will want to show something processing or something like model or loading model or something of that sort. It depends also. Everything will depend on the what kind of data set
we can take this off.
Yeah, I will take you offline. Any other question?
Abid will take this offline. Thank you. So next up we have Ishan Dutta from Adobe. Give it a round of applause for Ishan.
Visible? Screen share with me.
Hello everyone, how is everyone doing? My name is Ishan. I am a machine learning engineer too at Adobe, and today I'm not here to give a talk. I'm just here to have some fun. I will ask a couple of questions in between. Want to keep it interactive and make sure that you enjoy the talk thoroughly. So let's start with a very basic thing. Just to keep in mind the language of the talk, I would like, can you just raise your hands if you can understand both English and Hindi? Just show me a raise of hands if you can understand both English and Hindi. Good. We will keep it just to English. Now, just want to check, is there anyone named Rahul in this crowd? There is none, right? Chalo, I am saved. Oh, if there was, you would have killed me after the talk. So let's begin. The original title of the talk, which you would have seen on meetup.com, was getting started with vector databases. And but this is something different. Are we going to have a technical talk in the next 20 minutes? Or I'm just going to rant about a bunch of things. Let's see. Before we learn about that, I would like to introduce you to Rahul. Rahul is a 6 feet guy working in finance and he has blue eyes. Okay. Rahul is very active on dating platforms and he is always stuck on his mobile phone. Can you even guess the app which he uses the most on his phone? Bumble. Yeah, that was the correct answer. It's Bumble. But Rahul is trying to date a bunch of girls. And this is an actual story, by the way. And I have a screenshot from WhatsApp. And that guy is going to kill me. I did not allow him to come to the meetup. And he starts talking to this girl called as Ria. And they happen to be chatting. And this is one of their chats. Not sure if it's visible till the end, but I will read it out. Rahul says, "Hey, what's up?" She says, "Nothing, yaar, just frustrated with these shopping apps. Why? What happened? I wish there was a way that I could have one app and find all the similar dresses at one place." Rahul goes up and he says, "What if I make one for you?" Keep in mind, he has nothing to do with AI. Okay? That guy is not even into tech. Okay, but he just promises that what if I make one for you? And she's like, "Seriously, can you do that?" He's like, "Yeah, I can, give me a day." And she's like, "Okay." Then Rahul comes up to me. Ki bhai bana de. What happens next is a bunch of funny things because now Rahul doesn't just want the app. He also wants to understand how that is being built. So what Rahul does is that he will actually take his phone first and we will go to see how Rahul is going to build a quest to build a search engine. The first step that Rahul is going to do is that he will take his phone and he will kick it out. Okay, and he will get his Mac to start working. Now there are a bunch of things that Rahul needs to know before he can build something of this sort. Okay, what we are going to build is a vector database that can have and host millions of images together, and you could parse them from any website. Okay, that's up to you. You want Amazon, you want Mitra. In this particular case, I did it from one particular website. I will keep that to myself. I'm not sure if that's completely legal. And yeah, and then what he will do is that he will want that if I upload any image, okay, let's say I downloaded an image from Mitra and I upload any image, I should get the similar images and it can be from any site. So that you can have one app and you can shop from any website. Okay. So they run to me, of course. Now the first term which comes up to Rahul when he is looking about how to build a vector database is called as an embedding. How many of you have heard of this term before? Can you just raise your hand? Right. That's fine. We'll go back to the basics. Computers don't understand words. What do they understand? numbers. Correct. So if you have to build something of this sort where you can give an image and you can find the similar images in your data set, you have to find a way that you can convert that image into a form of number. When I say you want to build an embedding of something, just think of it as in your mind as if I have given you any word, and any word in the world. It can be a and the, it can be address, it can be an image, okay, it can be anything. Regardless it is the image or it is a word, everything can be converted into an embedding. I have a very good visualization which I would like to show, which will help you understand what embeddings are. Does this graph make any sense to any of you? Can I just have a yes or a no? You can shout it out, man. It's good. No, right? Most of you know. Some yeses I heard. Do you think these are random points? Yeah, you can just, man, there is no points for correct answers or wrong. Just feel free. Okay, I'm not judging anyone. Just whatever your heart says. Do these seem like random points or not? It does, right? But they are not. If I zoom into this, you can see each of these. This side, yeah. You can see that each of these dots are actually representing a word. I am pretty certain you can't read it towards the back. I will read it for you. Okay. So there's this word, this particular word over here, reading as Batman. Okay, you have a lot of words over here, like this particular word, bubble kind of a thing. Over here reads voice. So what is this particularly? Is that someone came up and he took a very large database, a vocabulary kind of a thing. Let's say I give you a dictionary, and you take that dictionary and then you pass it to a model, which is called as an embedding model, and it gives you a certain bunch of numbers. So every word is represented by a number. So let's say this word over here, let's say this word, this particular word is called as paperback. This is actually a number. Now, if you have a number, you can have, let's say, if you have just a single line, and I give you the number 5. Can you imagine where that number 5 will be? If you have markers like 0, 1, 2, 3, 4, 5, you can imagine where that 5 will be, right? That's just one dimension. If I give you 2 dimensions, like an x-axis and a y-axis, and I ask you to plot 1, 1, can you do that? It's simple. Similarly, you can do it in 3 dimensions, you can do it in multiple dimensions. Now, in general machine learning, you have n-dimensional data. You have millions of dimensions. Okay, and it's very difficult to understand which 2 points are close. If I just give you a single line and it has just 0 to 10, I give you 2 numbers like 5, 7, and 10, and I ask you which is the closest to 5. What is close to 5? 7. Okay. Similarly, these are not random points. If you think of these as numbers and the number line example which I gave you, the points which you can see closer to each other have some meaning because of which they are closer to each other. Now let me give you an example. If I just go over here and I search like any word, let's say car. Here I can select the number of closest words which I want. I'm setting it to 5. Okay. So you can see, if it's not visible, I'll just read out the words which are coming up. So with car, you can see the words automobile, it's racing, okay, there's a driver, and so on and so forth. If I increase this number to 15, you will see aircraft, vehicles, and more cars are there. What you need to notice is that all of these words are kind of on the same side of this random set of things. Right? If I change this something to, let's say, India, let's say what happens. I want the top 5 words, right? You see the words are like China, Pakistan, Bangladesh. How are these related? Most of these are names of countries. So the names of countries are at one part of this. Now you will be thinking that Ishan, but we were talking about images, dresses. What do these words have to do with it? Right? As I told you, an embedding model cannot just generate embeddings of words. It can also convert embeddings of images. So if I give you a different data set, how many of you have heard of the MNIST data set? MNIST data set. Okay, it's one of those first data sets which Jan LeCun worked with, actually created also. In that data set, what you have is that you have images from numbers of 0 to 9. So every number is an image. You can think of it as, I give you an A4 sheet of paper, you just draw 0. In another page, you draw 1. And you have thousands of such images. You pass it to the model, and you tell the model that this particular image, which you can see just around, is called a 0. Okay, such that you have 0 to 9. And at the end of the training, the model will be able to identify that you give it any number with written on a paper. It will be able to identify which number it is. So this particular round over here, you can see these are not numbers; these are actually images of numbers. That's why it looks like kind of a square. So you can see numbers like 0 is here, 4 is here, 3 is here. This also looks fairly random, but things will get fun if I convert this. Let's say I put a 0 over here. Just a second. Reload this. Yeah. Yeah. Can you see that all the zeros are actually on one side of the graph? Okay. If you just take any number, like let's say 1, it's on the other side of the graph. Now notice one thing very subtle. Okay. You found all the zeros over here. Okay. You found all the ones over there. There is a lot of gap in between. If you think clearly, how do you actually draw a 0? It's a perfect round. How do you write a 1? It's a perfect straight. There's a lot of difference between something that is very round and something that is very straight. That is something your model understands. Okay. But what if I would change this and I would make it a 9? You see that this 9 is not just concentrated on the top, it is actually towards the center also. Why is it so? Because if I change this 9 to a 6, you can see there are a lot of 6s in the middle. So the machine learning model from this graph, you can see that it might get confused between a 9 and a 6 because they have similar characteristics. Okay, both of them are kind of the same shape, but they're just flipped around. So from this, I hope with these two charts, you're able to understand what an embedding actually means. Okay, given anything, it can be a word, it can be an image, and if the model can do both of the things together, it is called a multi-model embedding. That you can give it a text, image, and it will arrange things in a way, in a space, such that each of these things are related to each other comes at one place. Is it clear to everyone? Yeah. Can I have a yes? Yes. Awesome. Okay. Rahul understood this. This is pretty fair for Rahul. Now the next thing which comes up for Rahul is called as index. Has anyone heard? What does an index come in mind? Would someone like to answer that? When I say index, or quickly looking up something, okay? Anyone else? To find the uniqueness in elements. Anyone else? What does index come? What is the first word thing that comes to your mind when you heard of unique identity? Cool. Now let's think of this example. Okay, when I tell you that you have a data set, just millions of images in it, and you need a way that if I pass one image, we can find the closest image to that. Doing that for a million images is very, very tough. Okay, the graphs which I showed you were actually pre-computed. A lot of them, not the ones, some PCS were calculated. But if you do that on a million and billion scale, you can't really take the embedding of one image, calculate the difference with a million images, and then pass the result to the user. Okay, maybe generations would pass and you wouldn't find the right dress. So you need to find ways in which you don't actually calculate the difference with all of the images. Okay, instead you can find the images which are more likely to be related to your search. So Rahul, what he does, he wants to find a mathematical metric, okay, such that he can calculate the difference. Let's say you have two numbers. Let's say you have 10 numbers, and I give you one number as a query. You have to find what is the number closest to this number. In mathematics, you are just using subtraction, right? You will just subtract the two numbers. You find which is the closest. You will give the answer. Here things are a lot more complex. So you need a metric which can handle multi-dimensional data. So Rahul goes to a library, which I asked him not to. And this is what he finds out. The library is a complete mess. Okay, there are books on maths, there are books on physics, there are books on business, and they're not really arranged in any particular order. So it's like any row, any rack can have any book. Is it easy to find a book which can give you the metric in such a scenario? Yes or no? It isn't, right? Think of it for a moment in your mind. It's very important. It's very easy to read the definitions. It's very important to build illusion behind things. And that is what we are going to do in the next 5 minutes. Think of it, why your mind is not able to process so much randomness. Why is it that your mind is actually thinking that it will be a very tough job and a very slow job, okay, to find what is the right book for it. if I help you out a little, and Rahul also got puzzled by the way what to do. If I help you out a little and I arrange these books in an order and I give you different racks for maths, physics, and business, is it easier now? Why? We have labeled data. Anyone else would like to answer that? Yeah. Search space decreases. Awesome. And yeah, you can do search. Now, how many of you think the answer is in the math section? Raise your hands. So I will repeat the question. Rahul has come to a library. He is looking for a metric, okay, like subtraction, which can help him find a way to calculate the closest embedding. Okay. So which of these sections are more likely to have that? Math. Physics. Someone said physics. How many of you think it's math? Just raise your hand. Arey, itna mad daro yaar. Raise your hands. Cool. While most of you think it is maths, there is a very small percentage of chance that it might be physics. You can't say it's zero. There is a very small percentage of chance that it can be business. I framed it in a way that I told you about subtraction. I told you about number lines, that you are meant to think in a way that it's in maths, but it can be in physics. It can be business. Okay, but the probability is very low. Okay. When you are talking of millions or billions of images and data in general, we are fine with ignoring that kind of problem. Okay. So what Rahul also understands is that once I have such sections, I can just let go of the other sections. I just need to focus on maths. How many books over here do you see? 3 books, right? In reality, there are millions of books. Okay. Now, once you have narrowed down your search space, okay, think of it very clearly. What we are trying to do is that you have millions of books. You're trying to find that 1 or 2 particular book which is best for you. We narrowed down our search space by knowing whatever cluster we have, in this case maths. But here also, let's say we have 1 million books. So we also need to narrow down our search space further to ensure that when Ria goes to that app, she can see that dress immediately and not the next. Okay. So what we will do now, we will do something which is called as giving them codes. So I have 2 sections over here. In the first section, you can see beginner, intermediate, and hard. I have labeled them as 0, 1, and 2. And in the second section, you have popular and non-popular. You have 3 and 4, like which is the most popular book, which is not a very popular book, and what is the difficulty level of the book, right? If there was a way, we could have assigned these codes to the books. This is something it would look like. Let's say book A is very hard and it is very non-popular. Book B is intermediate level, kind of popular, and book C, it is beginner as well as popular. And I've just numbered, basically created vectors like 2, 4, 1, 3 from that mapping. What is the book you think that Rahul is most likely to pick? See, how many of you think it's C? Just raise your hand. Lock kar diya jaye? The correct answer is C. Technically, there cannot be a correct answer, but we can. Let's assume there is a correct answer and it's C. The reason you thought it's C, and again, I made you think it's C because I already told you that Rahul does not have any context. The reason is that you can have this code for multiple number of books. Okay, so this thing 0 and 3 can exist not only for 1 book but for multiple number of books. Let's say you have 1 million books in your schedule, and for 100,000 of them, this is true. Only for those 100,000 books, then you can run your whatever metric Rahul finds out from these books, and find that one particular book which is the closest. So you see, we had a search space which was of multiple millions. We narrowed that down by creating such racks of maths, physics, and business. We narrowed that down further by using codes. Okay. Now, whatever you learned, there are 2 very good jargons over there within indexing. The first one is called as, it's a very shimmery name, inverted file index. And the second one is also a very shimmery name, product quantization. Do any of these words make any sense to anyone of you? Does anyone know what these words mean? All of you? All of you? The example which I showed you are actually doing this exactly. Okay. So what inverted file index does is, when you give any database or anything like LanceDB uses, by the way, IBF and PQ together. You give it to a vector database like LanceDB, first runs IBF on it. IBF what it does is, it creates different clusters within the dataset itself. Like the way you saw, we created maths, physics, and business. That's the step 1. In step 2, we do product quantization. So I have been telling you that whatever images are there, whatever words are there, we are representing them as numbers. These numbers, you can think of them as vectors. Okay. These vectors, what I can do is I can break them in different parts, like I did with beginner, intermediate, hard, and popular, non-popular. So within those numbers, which you can think of a book, I have also broken them down in different parts, and I'm searching what is the closest part. Okay, so that is product quantization. So you know both of them. I'm not going to define them here because the definitions are really scary, but you have the intuition behind them. What is it, why they work, and why they're necessary. Moving on to the next thing, we have something which is called as a schema. How many of you have heard this word before? A lot of you, right? I expected that. Thanks. A schema is really simple. Now, when you're talking of a database, you have to have some way of representing the data. In the simplest of words, you need to have a table where you have the data and you can find whatever is your query. A schema generally looks like this. It's a very simple thing. So I've been talking about embedding. So this is actually an image. We have represented, we have a model, it just converts it to a number, and you have different numbers. I have also kept an image source over here. Like let's say I downloaded this from Amazon, I downloaded this from Mitra, I downloaded this from Ajio. I neither confirm nor deny that I have used these datasets. And why I have kept it over there? Because the end objective was to return the URL, which we won't be doing because of legal concerns. And man, since I have come in Adobe, I have to think of a lot of things. Yeah. So the next thing that we have, let's see the code for it. Now, how many of you are familiar with Python over here? Few of you, that's fine. This is really simple. Okay, can someone give an estimated guess? Give me a range of the number of lines of code that will be required to build an application where you can just upload an image and you can find 5 closest images to it. Yeah, 10. Okay. Anyone else? Huh? 50. Okay. Anyone else? Maximum 10. Okay. Anyone else? Maximum 20. You can actually do it in 10 lines, but I like to write a little better code so that people can understand. And yeah, but it's very few. What are the important steps that you require over here? Okay. Now Rahul is smart. Rahul has figured out the steps, and he is on his way to impress Ria. The first step will be creating an embedding function. Given any image or any search query, you need to convert it to a number. That is how we will see in the first step. Second is the schema definition, more table creation. Then we have creation of the table, and finally we turn the vector search. So what is the embedding function? When you're using LanceDB, by the way, LanceDB is one of the most popular open source datasets, vector databases out there. And the reason I recommend LanceDB is also because you can just have it install pip install. You don't have to connect to a server or something. Just have it connected, and there are a bunch of more features. But you can see that LanceDB has a module called as embedding, and you can call a function called as embedding function registry. What you can do here is embedding function registry already hosts multiple of the AI models which are there for creating embeddings. So you can just pass the name of the model that you want here, and is supported by LanceDB. For example, in this case, we are going to use OpenAI Clip. Why are we using Clip over here? Because Clip is multimodal. It can also understand images. It can also understand just these. Actually, this is technically just 2 lines of code. Will help you generate an embedding. You don't have to worry about how many dimensions are there. You don't have to worry how to install the model. Anything. LanceDB will handle everything on its own. Step 2 is a schema definition, which is also pretty straightforward. So what we will just do here, we have just loaded the model. You just, as I said, you can just pass the name of the model. I passed OpenClip, and I create a class called as Mitra, and I just defined 2 columns. Like in the one which you saw, one was an embedding column, the second was the source column. Similarly, we have a vector, which is the embedding column. So I'm just telling Clip that this is the vector column that you have, and image URI is basically the source of that. So I'm telling Clip image URI is the source column that you have, and this part over here is just used to open the image. Third step, very simple, table creation. You can ignore the above part of the code. The most important thing is here that in a single line of code, which is table is equal to db.createTable, just pass the table name, pass the schema, and you have your table created. You can pass the dataset as well later. Okay, here I have taken 1,000 samples. I don't think it's visible till the end, but I have just taken 1,000 samples because embedding creation takes a lot of time. So I have a GitHub repo. In that also I've set it to 1,000, so that you can run it on any laptop locally. You don't need a very high-end laptop for this. So you have created your table, and finally you have vector search. Okay, how many lines of code will this be? 5 lines. Anyone else? 1 line. Okay. 5 lines. Ignoring this part, it's actually just 3 lines, 3 to 4 lines of code. This is just giving you the paths of images. This is 3 lines of code. You just connect to the database. This is all stored locally, by the way. You just open the table using db.open-table, and you can just run table.search, and you can pass your search query. It's that simple. Now, what can be the value of this search query, which is over here? It can either be a text search. Let's say I want to search for a white kurta, or I can just upload an image of a white kurta. You can either pass an image directly, load an image using PIL or OpenCV or anything, or you can just pass the string of a text. I will show it. It will be clear. Everything. Now we have a live demo. It's a very short demo. I think we are short on time. We have just 5 minutes more. Yeah. Is it visible? Okay. So what I have typed over here is, let's say, just let me just search for a jacket. So this is where you put your search query. There are 2 ways in which you can put your search query in this. The first is you can just type it out like you do in any shopping app. So in this, I have just written a jacket. It was fairly fast. Why was it fast? Index. Right. So this is a jacket. I have just limited the number of results to 3. You can increase it to as many as you want, and you get jackets. But this is a very simple example. Can we get a little more, what do you say, specific? So let's say I want polka dots on my dress. Not my dress, basically. Polka dots. Let's say I want to search for a top which has polka dots in it. Okay, it showed up. You can have more dresses. Okay, this is also very similar. This is also very similar. The second way in which you can use your application is that you can just go over here, you can browse your file, and you can upload any of these. Let's say I'm looking for a pair of jeans. Yeah, and I can run a vector search. You can find all similar. In this case, you have the image IDs with yourself. So using the table, you can fetch which URL it was from. I did not put it in the actual app because this is hosted somewhere, and I can't be using the data. And yeah, you can use any other image as well. Let's say I use this one. You can run vector search, and you have all the similar tests. That's it. After Rahul made this, he shared this with Ria. Hey, guess what? Ria guesses we are going to Rameshwaram Cafe again for the 100th time. He's like, he just laughs. Nope, I built something for you. Just check out fashionsearch.com. This is not a real URL, just hypothetical. She's like, damn, I'm impressed. Who thought he will get a little bit of appreciation over here? That does not happen. Instead, Ria says, I'm going to shop, talk to you later. Bye bye. So Rahul won, but at what cost? That's it. I hope you all were able to not just understand what are the important concepts behind vector databases, but you were also able to gain the intuition behind them. And what are these concepts? What do they actually mean? I generally like to spend a lot of time thinking about things. And I think everyone here is an engineer, most of you. And it is very important that you spend your time thinking about things and relate it to the real world. The moment you start doing that, I think it becomes very easy for you to not just memorize things, but actually have everything in your mind. And that's my QR, by the way. You can scan this. You can also find the GitHub repo with all the code in this URL as well. I like to have this for myself. I'm an engineer who plays electric guitar. And apart from Adobe, I also work remotely with Lightning AI and LanceDB. The first question which I get whenever I present this is that, are you moonlighting? The answer is no, everything is close to my employer. I'm also global brand ambassador for JavaScript AI and a top ranker in multiple ML hackathons. And yeah, this also has my music page, multi-instrumentalist. I play guitar, drums, and keyboard, and a bunch of more things. If you want to follow me on my socials, scan the QR. I also already said the GitHub repo is also there. And yeah, that's it. Any questions? Yeah.
First of all, I mean, you did a great job in explaining the way you articulated as well as your PPT deck, right? Pretty sharp and neat and clean. My question is about when you do about a vector search and embedding, right? Is the whole purpose of embedding is to find a similar whatever you were searching, you wanted to find the most similar content, right? Is there any other purpose for which embedding we do, and what are the other use cases which comes out of it?
So there are a lot actually. The very first is recommendation engines. Like if you use any music app like YouTube Music or Spotify. So whenever you are playing one song, you can see that multiple songs come to show up. How is that coming up? Because every song also has an embedding related to it, and the songs related to that, plus with your personal preferences and the location that you have, a bunch of those things combined together are help used to give you some recommendations. So it's not just about finding the most similar thing. Embeddings and vector databases are generally used with a bunch of other things. It is not just like you will just create an embedding and you will find the best fit. Because I was giving the example of Spotify. Let's say there is one song which you are listening to, and there is one song which is very close to this. Okay, but it might be that based on your listening habits, you might like some other song. So you generally club these vector embeddings and vector database with a bunch of other things and put them all together. Similarly, you do that with Netflix and YouTube, the video app as well.
I mean, apart from recommendation engine, what you're talking about, basically,
Yeah.
right? Is there any other reasons for which embedding can help you or can fix other sort of problems?
Yeah, there are actually, I can show it to you. Yeah. So others can also take note of this particular website. This is GitHub project called as VectorDB recipes. And in this, you can see how LanceDB has created basically a bunch of projects which are around this. So you have like a multimodal models, okay. You have vision-centric exploration, and yeah, vector search, you have audio search, you have multilingual search, you can have face recognition as well. Okay. Let's say you can have basically a bunch of things. You can also use a bunch of people also use this in chatbots as well. So all of those examples, if you want to go it in detail, you can just refer to this. It's like I think this project is also part of VectorDB recipes. Yeah, here you can find okay, YOLO Explorer is also there, and yeah, this one, multimodal fashion search engine. So similarly, you can find like all the similar kind of examples using embeddings in this page.
Thank you.
Anyone else?
We'll take the other questions offline. Give it a round of applause for Ishan. I hope a lot of you might have learned something new because this was like super AI focused, and we are like developers. We just know OpenAI APIs, right? And this was really
Okay, so I got the green signal. We are all good to go. So how is everybody doing today? Why are you so low energy? अभी समोसे खाए सब. अभी दो चटनी के साथ. So I hope everybody is in a good mood today. My talk is generally, I don't know, there's something with me. It's always the last talk. Maybe I'm not in on some joke. So I try to get the crowd into a slightly higher energy mode compared to what's expected of a last talk. But the topic that I'm covering today is something that's very interesting. It's called control flow based rendering. I know that means nothing if you're new. But who here thinks of themselves as a procrastinator? That guy. But I personally think that I am also a procrastinator. But my belief is that to be able to optimally use your brain at certain parts of the day, you have to let it rest for the other part. Right? You cannot be functioning highly for 20 hours in your whole day, right? Then by definition, you're not being productive, right? Then you don't have any productivity spikes. So what I believe is that you should spend as less time working and as less time coding, and then spend the time left in, let's say doing some recreational work, meditating, going to the gym, or meeting your friends, right? But there's an issue with this JavaScript and front-end development ecosystem especially, and that's part of the reason why I'm not a huge fan of React, is the decision making and how quickly it changes, right? So there's this slide. I am a software engineer at Microsoft, as I guess you already know. I used to work in a startup called Pressure Policy. I used to be a LinkedIn top voice, and I like to think of myself as an imposter web developer. You'll find out why. So I am one of those people who likes to lead code. Okay, so I am one of the exceptions, I guess, here. But in general, I like to tinker with technology. I like to work in generative AI. I like to work in web development. I like DevOps a lot. But to be able to be a generalist and to be somewhat productive at a wider span, you need to limit your information. I don't look at news. I try to have a less information diet. I don't want to know a lot of things because that's how I feel my brain can function well. I don't need all this information. Just give me the basic stuff, I'm happy, right? But every time I come back to web dev, every 3 months, every 6 months, I feel overwhelmed. It's keeps changing. So I learned JavaScript, but then a year later I learned that, oh, that's not a cool thing. You need to know TypeScript now, right? And TSX, right? Then I learned React. I was terrible at it, but by the time I got good, there were 3 more frameworks. Why? Right? And Angular, let's not get into Angular, I just didn't do it. Svelte was good though. But then I thought, okay, let's pick up a styling library. Bootstrap was good, right? Nah, it went out of fashion the year I joined college, 2019. Right? So Tailwind was the new thing. But now I guess the new kids are using something called Shad CNUI. I don't get the point of it. It makes no sense. Right? So you keep changing. And that's why I hate web development. Right? Can anybody relate? Maybe you don't hate web development, but you don't like this small, short-lived life cycle, right? And they keep coming back to the same concepts as well, right? Use PHP or what was it? Use JS or something in the server. Use server, right? They are back to PHP now. Right? But it's not it. You learned the framework, now there are meta frameworks. It's like Inception, right? And then they put it on the edge. You learned, okay, now I know client server model. They're like, now no, learn edge. We'll put your code on the edge where it's not supposed to be, but we'll put it. Right? Does it work? Sometimes. Let's not discuss Dino and Bun. If you don't know it, you have a good life. Don't Google this or bring this. I'm from Microsoft. So this is called analysis paralysis, right? If you have to start a new project, how do you start a new project? You are supposed to create an empty repo, create HTML, CSS, JS files, and get started. But now that's not the case. You have to figure out a bundler, a framework, a styling library, a language, a runtime, and a deployment environment. Why think all this, right? If you're just making a to-do app or you have a startup idea and you're just building a POC, why do you need to know all this? Right? Why do you need to make these choices?
can't there be reasonable defaults? And why do we JavaScript and TypeScript developers have to know all this? Because there are a lot of simpler choices like Django, which are very opinionated. Python also has, Streamlit, Gradio. They're able to put together UI so quickly and efficiently, and it works for the most part, and that's what most POCs are all about, right? So I took my therapist's advice, and they said overthinking is not good for you, and I built a framework. And I call it Backroad. So those who don't know, Backroad is like a quieter and smaller road which is often detached from a main road, and it's quieter and easy to go through. That was the vision behind Backroad, and I built it over a month in 2023. But how does it work? I say if you know how to write a while loop, a for loop, and if statements, you already know Backroad. And you can build quite complicated UIs and full stack web applications just using for loops and if statements. If you don't believe me, the next 10 minutes might surprise you, right? So this is some sample Backroad code. I will not go too deep into this because I know most people will not be able to see it. But we will also do a deep dive. But what this is essentially doing is, it's basically a UI where it's asking, are you a dog person or a cat person? And there is a toggle. Okay. If the toggle is on, there is an if statement here which says if dog person equals to true, it renders a dog. And if it says cat person equals to true, it's a cat. And it will automatically take care of the rendering and removing the other element from the DOM. You don't need to know React, you don't need to know JS, you don't need to know Bootstrap, Tailwind, whatever. With just 5 lines of code, you can write a toggle, give it a label, and render condition. 5 lines of code. But this is not the most interesting example. You can do a lot of things just using one-liners in Backroad. You want a color picker, you do PR, which is Backroad, not color picker. You have a color picker. You do br.file upload, you have a file in your server. You don't have to worry about how it landed there. It was taken from the front end, it lands in the back end, you don't have to know. You can give toggles, you can build a whole generative AI app, which we will do in a demo today. With 30 lines of code, you'll have your own ChatGPT interface. End to end. Now, let's get into the demo. I'll sort of introduce you to a very simple example and then we'll get more complex. So there are sort of 2 demos. Let's see how much time we have. Okay. So let me zoom in. Can you see the code at the back? No? Yes? No? No? Oh. Let me zoom in a bit more. I hope now you can see it. Okay. I'll probably have to build a new framework for presentations. Not yet still? Okay, but I'll probably have to be a little bit more accommodating to everybody, so I'll also voice out what I'm saying. If you can't see the code, you can at least hear the code. Okay, so I'll show you a sample Backroad app first. Okay, now this is a sample Backroad app. And this is all built using a single file, single JavaScript and TypeScript file. It's a triple page application. It has this UI, it has links. If I click on the read the docs, it will open the Backroad documentation. And it also has a sidebar and I can navigate to this forms and files UI. So I told you I have a lot of form components, right? You can add a file picker. Then you can choose toggles, you have checkboxes, you have toggles here as well, and you can have numbers and strings, right? But this is boring. Let's build our own app. And all of the Backroad code is inside this run function. There is a run function here which has a lot of code. I'll clear all of it, and then let's proceed with a simple demo. I save this, and now it will clear itself. So now we have a blank canvas, okay? And by the way, for every Backroad app that you have light mode and dark mode support out of the box. Okay. Now let's say I want to have a simple calculator. Okay. I'll copy this code that I have at the top because I cannot type right now. I'll say br.write calculator app. Can everybody see the code or at least gather what's going on? Yes or no? Okay. So I say br.write calculator app, and you see this is markdown. If you notice carefully, this is markdown code. right? See how this renders in the UI. It rendered as a heading, right? Now, let's say I want to take a number input. Now, you will really enjoy this, right? So I say const call1, call2, and I got two BR columns. You remember how Bootstrap has this columns concept? You get two columns just by this, call1 and call2. Now, every write call which you give to the call1 instead of the main backward object will go in that column. So it's all recursively DOM elements, okay? And I can even adjust the proportion. So if I say 2, 1, so the left column will be twice the size of the right column. Very simple. The whole concept of Backroad is to keep things as simple as possible. Then I get the number 1. See how simple it is to take a number input. Num1 equals to call1 dot number input, and I give a label and a default value. Everybody sees this, right? See how this looks like in the UI. You already have a UI element. Interesting, right? Now, since you have one number, you can always have another. And then it's all JavaScript. So now you can do a sum. Const sum equals to num1 plus num2. All the typecasting, all the backend to frontend linking, all the APIs. You don't care. You don't care about the logic. Now, let's use the column 2 and say the sum of num1 and num2 is sum. Let me zoom in. And does it work? Let me add the number. So 5 plus 6 is 11. I think you're all with me with this. 6 plus 6 is 12. Automatically it updated if you saw. Right? But that's not where the functionality ends. This is a simple UI. Let's add an image, okay? I go to the next line. I add an image. And this is a new feature that I rolled out which was not there in my previous talk. Now Backroad supports local images. So if it's there in your file system, there is a file in the same directory. And I say I don't want this one. I want a calculator image because it's a calculator app. I think it's calculator.png, and I save it. See? That's how you render an image element. And you can also make this dynamic. Let's say it's coming from an API call. As soon as the br.image call is updated, it will re-render. So how is this working essentially? How it's working is that every time you change a value, a number input, or you do any activity on the Backroad screen, it will render the UI from top to bottom and clean up any previous iterations. Let's say if the number 2 becomes even and I want to stop rendering it, I will say I will stop doing this call1.number input call if the previous number is even, and because it's in an if statement, it will never run and hence never render. It's very similar to Streamlit, okay? If you have used Streamlit or Gradio, these sort of things, which Ishan showed. So technically every talk that we have had today can make use of Backroad to build a quick UI on top of their existing Node.js code because it's a Node.js environment, right? Now let's move on to a more complicated example. I promised you a ChatGPT clone, okay? We'll do it in 30 lines of code. But first, let's make this from a single page application to a multi-page application. Yes, you can build multi-page applications just using Backroad. Adding a single new page to the Backroad interface is very easy. So what I will say is just how I was doing number input calls, I will do Backroad dot page. Okay? And I will say, give me a page at the href, or I would say at the path of GPT. And how do I use this page now? Because Backroad works recursively, I will say just give me GPT. And now every call to write number input that I give to this GPT object will go to the other page and not this page. Very simple. Is everybody clear with me so far? Yep. Now let's get ahead. So I have this other function which is supposed to build the GPT clone. I'm calling it GPT page handler. Okay, so I'll pass this GPT object because I want to write it in a new file and just pass this object here. And now I'll have a whole UI on the /GPT route. I have a UI. But let's clear this up and write it line by line. This is a finished demo. So see what's happening here. If you look at the GPT file, the basic code is very simple, okay? I think this is very similar to any OpenAI project that you configure. You open an OpenAI SDK, you pass a ELB variable which will have my API key, which I cannot share for security purposes. Then I will use this client to do my chat generation, okay? Now, I say br.write, this is a GPT page. This is pretty simple, it's this heading that you're seeing at the top, okay? Now, what I do next is I again make two columns, but now make them 4, 1, because I want a search input which is 4 times the size of my clear chat button. Okay. Now, the next step, I have a chat input component, which is this text box right here, and then I have a clear button component. And see, this is the if logic statement which I was talking about. If clear button, this if clear button only evaluates to true for one time when you click it. The next time it will start evaluating to false, and you will not have clearing inputs at every click. Only once. See how powerful of a UI you can make just using if statements and for each. We'll build a whole ChatGPT UI just using if statements and for each, as you can see. So if statement helps me in clearing. The next is if message. So every time a message gets entered into that chat input, only once it will evaluate to true. And I push that to my message array. I have an array called messages, which has messages from both the GPT agent and the human. Okay, you'll see it. So message is basically an array which has 2 fields, which is either the name of the person, human or AI, and the content, which is the message content. Now, as soon as the message input comes, I push it to my array, and then I also feed this new message object to the GPT completions API. Client.chat.completion. This is not something I have created, it's the OpenAI object. And I get the response back from the AI. And I'm using GPT-4o for this. And for every completion that I get, I also push that to my messages array. Okay, so for every push by the user, you also get a push from the AI. Now for each of the messages, I again render this VR component, which is VR.chat message. We haven't seen this on the UI yet because the messages object is empty. Okay. Now let's say I ask him give me code to calculate Fibonacci series in Python. And I hit enter. So this is my user input. Now it's waiting for the OpenAI input. Okay, the OpenAI response. So as soon as the response came, because these are both chat message components, chat message, it will render it left and right and automatically figure out the rendering. And because Backroad supports Markdown, and most GPT responses, when you ask for code snippets are in Markdown, you get a chat GPT interface. So it's very elegantly designed for some commonly used scenarios. Okay, and if I zoom out, the whole of this ChatGPT interface code, I think, can be taught to a 18-year-old, who has never touched coding before. It's very simple, right? Because you just have a messages array, then you get your input, you put it into an array, you also feed it into the API of ChatGPT, you get a response, you also put it to the messages, and you just have ready-made components like input, clear. Now let's say I want to clear this response. I showed you how simply you can add a button, right? You just say call to dot button, and as soon as the clear button will click, the messages array is supposed to get re-rendered, right? Now you need to, when I hit clear chat, it cleared itself because only one time it rendered and messages were clear. I think everybody can understand that much, right? So this was the demo, a 30-line ChatGPT implementation, right? So coming back to my demo, my PPT, let's share this from view. How does this work? So you have your logic which you wrote just now, and it taps into the Backroad engine. Okay. Now Backroad engine has 2 concepts which are containers and components. The columns, the pages, they are containers. And you can think of it as a tree. A container can have more containers, but at the end of the tree, there has to be a leaf node, right? And those leaf nodes are components which cannot be recursed into further. These are image elements, number inputs, buttons. You cannot add more components into it. Okay, but these have associated values, numbers, strings, colors, color object can be there. And every time you do a state change, every time the component state value changes or the ordering of the container changes, you do a re-render. It's wasteful. But React is so smart because we all know that React uses virtual DOM, right? It will only make a change on the actual DOM if there is a diff in the virtual DOM and it's worth re-rendering, right? So there is a state storage, there is a render queue. So if you put a sleep call between 2 br.write calls, the actual second response will only render on the front end after the 1 second has elapsed. So it's sort of single threaded. Then there is a container component tree, like I just explained, and then there is node managers. You saw how I can chain a a column object to have a markdown and then markdown to have something else. There is this node manager concept which is there. You can check out the code. It's quite simple. And then each unique tab which you open with a Backroad session has its own data. So if this person writes 5 plus 6 and somebody else opens a different server, because your WebSocket ID is different, your state is isolated. Right? So you can support multiple people at the same time. So that's majorly it. If you like this project, this is basically a Streamlit alternative, and the reason I built this was there was no Streamlit alternative in the Node.js ecosystem one for one. So I built this. It's called Backroad. I go by the name of Sudomakes on LinkedIn and most other platforms. You can check out Backroad at backroad.sudomakes.art, and you can also check me out on LinkedIn. Thank you so much for your time, and I hope you enjoyed this talk. If you have any questions, I'd be more than happy to answer. Thank you so much. Yeah. So his question was, what is the role of WebSockets in this project? Now, because I know that there is a persistent connection that is needed between the client and server, and my components, because they are conditionally rendered, those diffs have to be streamed. So I could have used HTTP, but using a WebSocket and a single TCP connection can be faster, right? And because I don't have to really care about the traditional REST way of doing things, because there is no APIs that you are defining. As long as I can send a message to a channel which can be received off by all my receivers, it's good enough. So it's the reason why I use WebSockets. But yeah, there is a component to this, which is the file upload component, right? Now I cannot send files over WebSockets that easily. So for that, I'm using a normal REST API fallback. And then those sessions and files are tied together. Like, okay, this file belongs to this session, so the WebSocket sort of handles it all.
Awesome. Thank you so much for the talk. Give it a round of applause for Vaibhav. Cool. We'll just disperse for 5-minute break. Just come back in 5 minutes. I don't know, many of you might be tired. Like, just move around and make your session. After this,